Chemical reactions are generally the one in which reactants react and turn into products. So we keep on investing on reactants and we keep on getting the products. And we set all the parameters to change reactants to products, mean temperature, pressure, concentration, everything. And we assure that whatever we are doing with the reactants, they are turning to the products. Possibly we may be careful regarding their mole ratio and limiting factor, and we add them accordingly, but we assure that reactants are turning to products. But there are certain chemical reactions which are a sort of headache for the chemist and for the industries. And they are what? Reversible reactions. The name indicates reverse. They reverse back. Reactants turn to products, and under the same conditions of the temperature, pressure, whatever the condition you have applied for the reaction are, they start turning back to reactants. And the story never finishes here. Rather, there is a certain time that after which the chemist will notice that there is no apparent change in the amount of the reactants and the products. Mean almost the reaction is stuck to the state in which reactants and products are almost the same. There is no net change in the yields of both sides. Why it is happening? Because reactants are turning to products, and under the same condition products are turning back to reactants. And after some time there is a state reached that rate of conversion of reactant to the product or conversion of products to the reactant get exactly the same. As a result, you will not feel any apparent change, and amount of the both sides remain the same. And that particular state is called state of dynamic equilibrium. Depending on the nature of the reaction, type of the reaction, it varies. This situation varies from reaction to reaction. The reactants turn to product and product to reactant is stuck to the state of dynamic equilibrium, and this ratio varies. I mean, in some cases the dynamic equilibrium may be on a situation where there is 90% of the reactant left and 10% of the product, and maybe the opposite case, that 90% of the product and 10% of the reactant. I mean, it's not complete conversion, but this varies from reaction to reaction. Like ammonia industry will discuss in detail, ammonia is the basic thing needed for fertilizers. Ammonium nitrate, ammonium sulfate, ammonium carbonyl, mean urea, okay, calcium ammonium phosphate, calcium ammonium sulfate. Ammonia is the basic thing needed for all the fertilizers, because ammonium provides the basic ingredient, that is nitrogen, required for plants growth, and that is possible only when we have ample amount of ammonia in the market. But in the 19th century, mid 19th century, people were simply dying because of shortage of food. They were having money, but there was no food in the market. Reason was that population growth somehow has occurred because of the medicinal improvements, but food shortage. And the reason, because there was depletion of the nutrients in the soil as more and more crops were grown. And artificial fertilizers were rare because ammonia production was rare. And what was the reason behind this? Ammonia was formed by a reversible reaction, and production of ammonia, or yield of the ammonia, was very less. Like a factory running 24 hours a day was yielding only 1 ton of ammonia, because reaction was basically reversible reaction. But after the improvements in this particular case, in this particular field, reversible reactions, after the studies basically by the scientist Le Chatelier and later on improved by Haber, we know that the yield of ammonia gone so high that the same factory may be producing 1,000 tons of ammonia in 24 hours now. And we have plenty of ammonium sulfate and ammonium phosphate and ammonium nitrate and ammonium carbonyl. So these artificial fixed nitrogen is given to the soil, and soil has ample amount of the fertilizers, so ample growth, ample yield, and no shortage of food. Okay, so the scientist basically, the mind behind was from the Le Chatelier, and Le Chatelier has said simply, these are reversible reactions, one. Secondly, if a reaction is stuck to the state of dynamic equilibrium, that reversible reaction will definitely do so. Then in that case, we need to apply some rules, and the basic rule is, if a reaction is stuck to the state of dynamic equilibrium, you create a change, reaction will go against the change, will counter strike, and will attain the equilibrium again. Whatever change you will create, reaction will oppose that change. So chemist has to be smart. So in smart situation, he will change the pressure, temperature, concentration of reactants and products in a way that when the reaction opposes the change opposition should be in the favor of the product formation, and yield should be high. And that's what the Haber has done by using the Le Chatelier's rule. And that is the case. Basically we'll see in detail that how these reversible reactions can be can be tackled using what? Le Chatelier principle. We're going to see the ammonia industry in detail.